Okay. Okay. So what are the components in UVM we have? See, first of all, what are the advantages of UVM? The simple word I am saying, telling those things. Okay. So whenever I will be explaining the UVM, you will get to know details about those things. So in UVM, your advantage is one is factory concept. You can know factory override. Then TLM port. It is just the substitute of mailbox. Then UVM pages. Then config DB. These are the important things in UVM we have. Then fifth one is some predefined methods. That is already defined and stored in the UVM library. Okay. And UVM has the advantage of like virtual concept. It use virtual concept, or you can say simple polymorphism plus inheritance. These two concepts are used in UVM. That means in there will be one base class. In the base class, they have defined some methods, some procedures. So whatever according to your requirement, you have to extend your class from base class and use the user-defined classes. Okay. So now we will see in UVM we have two types of components. Okay. One is known as UVM object and another is UVM component.
What are these two?
Two types of, okay. It is just no, like whatever the UVM components, okay, UVM, let me take it, say it class components, okay. See, see, this is all the UVM component, UVM test bench, okay. This UVM test bench, we have this sequencer, driver, monitor. These things are defined into two parts. Okay, one is UVM object, another is UVM component. Okay. So UVM test bench, UVM test bench components are divided into two types. One is UVM object, and second one is UVM component. Okay, what is this UVM object? UVM object means, okay, it is like whenever we need, we can create it, and whenever we don't need, we can delete it. Or I can say they are not present end of the simulation. We can delete them whenever we don't need it. And UVM component, I can say they are present to end of the simulation. Just go back to system Verilog. Okay, in system Verilog, there is one driver component and one is UVM transaction component. Okay, so I can delete UVM transaction. Okay, UVM transaction, it is like no, just okay. So this is my transactor class. Okay, so this class, it is used inside the generator, driver, monitor, scoreboard. Okay, when inside the driver, okay, I am getting the values from the generator. I am sending it to the monitor, to the interface. Once I send all those values to interface, then I can delete transactor class. There is no use of transactor class. Right?
Okay.
You got that point?
Yeah, understood.
Your voice is very low.
Yeah.
Hello. Yes, tell me.
Understood.
You got this one, or should I explain once again?
Can you go once again?
Okay, now just think this transactor class, in the mailbox it is generated, sorry, in the generator class it is generated, then transferred to driver through a mailbox. Now once driver sends all those values to interface, do driver need this transactor class? Now go to this driver code. In the driver code, here driver is sending the values. Now let I want to send 50 number of values. After sending 50 number of values, I can delete the transactor class. There is no use of transactor class in the driver.
Yeah. Okay.
Okay. Now just think, okay, I have transactor class, okay. Just example. I am doing this write test, read test, and write followed by read test. Okay. So transactor class will be one class. We have different generator class. Okay. Now, once I am sending all the write test related values, I can delete the transactor class and I can create another transactor class for read. And once all the read related the values are sent, I can delete it. Right?
Yes.
Okay. So now the question is, can I delete the driver? No.
No.
No, because driver. So driver, see, for the write, once the work is done, I don't need the transactor class related to write test. But still I need driver because I cannot create, I cannot say that for write test, I'll be needing one driver. For read test, I'll be needing different driver. No, driver is same. You can delete this write test, but you can delete the driver because from the to the end of the simulation, driver should be there. Else, who is going to drive the values to the interface or to the design? So here I can say driver, it is a UVM component because they are present up to end of the simulation. We can delete them.
Okay, once we transfer the values
You can see, okay, just 1 minute. You can tell them like quasi-static.
Delete them whenever
Quasi-static. Static means what? Static means from the start of the simulation to end of the simulation. It is like module. Whenever I'm saying static, static means module. Class components cannot be static because we have to create them. When we create them, at that time only they present. Okay, so that's why I have referred this quasi-static. That means they are present when we create them, but we can't delete them till our simulation ends. But UVM object, during our simulation, we can delete them. We can delete them during the simulation.
Priya, I have a question.
Yes.
So, once we transfer all the values from the driver to interface, can we then delete driver because the job of the driver is done, right?
See, once we are driver and monitor, they require time. Okay, so driver and monitor work parallelly. So whenever I'm saying that my job is completed, my simulation is ended, that means driver monitor, all the work is ended. At that time, we will give $finish and we will come out of the loop. So you come out of the simulation. Once in the scoreboard, we do the checking part that don't consume time at all. Scoreboard part. Okay, the time consuming part is driver and monitor. So if I'm saying that my simulation is completed, driver work is completed, that means I am totally out of the test bench. All the components were deleted. It is not like that I'm only deleting the driver and keeping the monitor. All the things are ended.
Okay.
Okay, driver work is done means monitor work is also completed, and scoreboard work, it will take 0 simulation time. So I am out of the verification part. Then I have to check whether I have any UVM error or not. What is my functional coverage? What is my core coverage? If there is any assertion things or not. If all the things are working properly, then I can say that my design verification is completed.
So can we say that driver and monitor are running parallelly? Because
Yes.
you said that scoreboard is consuming 0 simulation time. That means, okay.
See, scoreboard, okay, this 0 simulation time, when I'll go to fetch concept, you will come to know. Normally in the scoreboard, we do the checking part. We don't write any time consuming things there. But yes, if you are saying that I will give some time #1, #2, #3, yes, you can give it. Okay, but mainly driver and monitor, you just see, but driver will be sending some signals. Definitely there will be some timeline, pause edge of clock, neg edge of clock, those things. So driver and the monitor is the main part which consume the time.
Okay.
Priya, did you say even in the monitor we can delete the object once we have no use for it?
This object part you can delete whenever you don't need. Okay. So
Okay.
in the UVM object, okay, in the UVM test image, what are the UVM objects? This UVM object
I have
is,
one question, Priya.
yes.
So the driver is taking the transactor class and then passing it to the what's that interface? Is it or
Yes.
the the interface? So we don't need any more of the transaction class, so we delete it from the driver. And from the monitor, why are we deleting again?
If we do say in the monitor, we will be sampling those values. After sampling those values, we will be sending to the scoreboard.
Okay, because we're sending to the scoreboard, we don't need to keep it in the
You
monitor.
don't need it, yes. So see here, I'm not saying that you just have to delete it. The thing is that you can delete it if you don't need.
Okay.
It is not mandatory. That's in UVM. Okay, we in the system Verilog it was transactor class. In UVM it is UVM sequence item. It is like
Okay.
SV transactor class. And this sequence it is like SV generator class.
Okay.
These two things are known as the UVM object, and okay, so we can delete them if you don't need. Okay. So now see this UVM sequence, it will be write sequence, read sequence, write read sequence, like that. So whenever write sequence part is over, we can delete write sequence and we can proceed to verify read sequence. Okay. So now, and here remember, there are some predefined methods. I told you predefined methods. So whatever the predefined methods you are going to use in your UVM test bench, you have to define here. Okay. So here I can write it they defines an interface of core class based interface, just like create, copy, compare, etc. Now, just for example, you want to use this copy method in your environment. That things you have to define here, either in UVM sequence item or in UVM sequence. Define means you have to mention here. Now let you are not mentioning that I am going to use copy method in my test bench here, then you won't be able to use the copy method here. So whatever the methods or whatever the things you are going to use, you just have to mention here. There is some certain format or certain syntax. Using that syntax, you have to mention here, either in UVM sequence item or in UVM sequence. We will see, okay, for how we do that. Okay.
Okay.
So now this UVM object, UVM component is completed. Then we will go to all the parts of UVM test bench. Okay. So it starts from UVM sequence, then UVM sequence item, then UVM sequence. UVM sequence item, then UVM sequence. UVM sequence item is nothing, it is like transactor class. So you know what we do in the transactor class. Same things we will be doing in UVM sequence item. It is like generator class. So all the UVM sequence item will get generated here in UVM sequence class. Okay. So here I can say it generates the sequence item that are input to duty. Okay. So next one is driver. You know the driver, what is the work of driver? It is like same in SP. It is the driver work. It drives the values from test bench to duty according to the required time. Whatever the time, depending on that time, it drives. Okay. So before driver, we have one sequencer. UVM sequencer, it is a component. UVM sequence, it is a object. Here I am writing the object. And UVM sequencer, it is a component. Get confused like UVM sequence and sequencer. Okay, so UVM sequencer, it is a component. So what is the use of component? It is like
Sequence.
You can say it helps in the handshaking mechanism. Now I have to drive the values from UVM sequence to driver, right? So here sequence item are driven from UVM sequence to UVM driver, right? Now UVM sequence, it is a object.
UVM sequence, yeah, it's an object. Yeah, you told.
Object and UVM driver, it is a component. Now, to maintain the synchronization between them. Okay, like see, let sequencer generated one value. Okay, then it's sent to the driver. Now, how a sequence will next know that I should generate the second value? Whether driver should send that values to the duty. Let driver is taking some time to send that values to duty. So after that time, sequence should wait. Sequence should wait when driver should send the first item to the duty. After that only, it should generate the second item. Else what will happen? Sequence will be generating 10 items at a time. It will be sending to driver. Driver won't be able to send those values to duty. Remember, in the mailbox, we were storing the values, right? But here we have TLM port. TLM port, it has the option, like if you are using it as a FIFO, then you can store the values, else you won't be able to store the values. Okay, so that means one by one transaction will happen. First one item generated, it will be sent to the driver, then it will be sent to the duty, then driver will say sequence that, okay, I am done with the first thing, then you send me the second item. Then sequence will send the second sequence item. So this synchronization is maintained by the UVM sequence.
Okay.
Synchronization. We will see that is known as UVM driver and sequence handshaking mechanism. We will see. Synchronization done by UVM sequencer. But here it is known as UVM sequence and driver handshaking mechanism. Handshaking means like driver should send back some signal when first transaction is completed. And UVM sequence should wait for that signal. So when driver completes, then only it should send the second. We will see. Okay, that is the one main important thing. Just for now, remember this UVM sequencer, it is just there to help the handshaking mechanism, UVM sequence and driver. It has other advantages also, we will see, but currently just remember this. Okay. Then we have UVM driver, then monitor. Then we have agent. This agent so this UVM agent, it is nothing but it consists of UVM sequencer plus UVM driver plus UVM monitor. It contains all these classes. So this is known as your active agent. We can have agent only consist of UVM monitor That is known as the passive agent. Okay, so see, so why we are using this agent class? See, this agent, remember in the UVM, you are using some FPB to I2C bridge.
I didn't understand, Priya. In UVM, let.
Okay, so let you are using some code that is FPB to I2C bridge. Then you have two components, like two part. One is FPB, one is I2C. Okay, then you have to use it. For FPB, you will have one sequencer, one driver. For I2C, you will have one sequencer, one driver. So sequencer and driver, it is like one-to-one connection. One sequencer can be connected with one driver. Don't think that I have one sequencer, I can connect it to 2 or 3 drivers. No. One sequencer is connected to one driver only. So here FPB, you will have one FPB sequencer plus driver. And that sequencer I cannot use for I2C. For I2C, we would have one sequencer, I2C sequencer plus driver. Okay. So this agent, it is like reusable. So what I can do here, I can use here one FPP agent. And here one I2C agent. So when I'm saying this FPP agent means it will have sequencer, driver plus monitor. When I'm saying I2C agent means it will have I2C sequencer plus driver plus monitor. So what is the advantage? Here you are using two I2C components. Okay, so you don't have to write that sequence and driver again. So here what is the advantage?
Priya, you said APP agent is reusable.
Yes, reusable purpose
And
only we are using.
Agent is reusable,
yes,
but it cannot be reused for two different components. It cannot be.
No, I did not get your point.
Because you said agent is reusable, that means but we cannot use it for both APB as well as I2C. We cannot use it.
No, we cannot use it. So see, different. That's why I said for APB, I will have one APB agent. APB agent I cannot use for I2C. Okay, then what is the advantage? Now in this FPP to I2C bridge, I have two FPB. Okay, so what I will do, I say this FPB agent, I have already declared this FPB agent. So I have to create two component or two instances of FPB agent. So here we have to create two instances of FPB agent. So here what will happen? Automatically two instances of FPB sequencer plus FPB driver plus FPB monitor will get created. You don't have to create them one by one.
Okay.
So you got that one, right?
Yes.
Just for here, let me explain. Now this is my FPB agent. So I have already declared one FPB agent where I'll have sequencer and driver and monitor. And here I have sequence also. And that sequence to driver connection is already made. This connection is made inside the agent. Okay. Now I need same two APB. So instead of again creating these things, again writing APB sequencer, again APB driver, APB monitor, then connecting APB sequence to APB driver, what I can do simple, I can create two instances. Okay. So now automatically everything to do is created. So that is the use of FPP agent. It is used for reusable project purpose and it encapsulates the UVM driver monitor sequence. Got it?
So how to create two instances? Are we going to create?
It is like create for two class component. We create two objects, na?
Two objects. Okay.
Two objects means only creating two instances. Okay. So now this UVM agent, it can be active as well as passive. Passive means it's just a monitor. Means it is simple sampling the values. Active means it is driving the stimulus. That means we would have driver. Driver is present means that is active agent. Only monitor, that means driver is absent means it is passive. Okay. So next we have UVM scoreboard. That is same as your SV scoreboard. Then we have UVM scoreboard, then UVM environment. Next is UVM test. Then top. And here remember we have optional of UVM subscriber. Functional copies. You can write it monitor in scoreboard, but there is extra class also UVM subscriber where you can write the functional coverage. Okay. So understood about all the components. Pranita is not asking anything. Is he there?
I'm here. You hear me? Yeah.
Yes, yes.
Yeah.
Okay. Okay. So now we will see what is happening inside this UVM sequence item. See, UVM sequence item only it will take 2 or 3 classes, because see what I said here, all the methods we are going to use, that will be defined inside this UVM object. That means let I want to use copy method, I want to use compare method. I have to mention them either in UVM sequence item or in UVM sequence. So it is always good to mention them in UVM sequence item. Okay, so now we will see what are the predefined methods, how we can use them. Okay, so we will start with UVM sequence item.
Priya, before
Yes.
that, can you show us the UVM environment and test like a diagram, you know?
Yes,
with
yes,
the
sure.
Thanks.
This is the UVM environment.
Yeah, you have it here. Scoreboard agent. Okay, there are
Here two agents are present. Okay. You just you can omit this left side part, huh? Just simple
Okay.
right side scoreboard, functional coverage, test, environment, monitor, driver, sequencer. Okay.
Yeah. Virtual interface. Why do we have like two? Like we are having two separate virtual interfaces?
No. Actually, one interface. If you remember, we pass from the environment one virtual interface. They have defined it like two. So you just think whatever the interface we're using driver, if I'm not using same interface for the monitor, then how it is going to sample the values? So it is like same. See, interface, it is like same only. They have defined it like, but one interface. For one part, we will be using like one driver, one monitor. It is like one agent. So one agent, one interface, one virtual interface.
So this virtual interface and the interface below that, are they both different?
The thing is that this interface, it is static. It is present from start of the simulation to end of the simulation. But my class, it is a dynamic concept. So dynamic means it will not present from the start of the simulation. So we cannot use static inside the dynamic. So that's why we are using this virtual. Virtual interfaces, it is just like a pointer to the interface.
Okay.
So when this will present, whenever I am creating this driver class, at that time only this pointer to the interface will present.
Oh, okay.
Okay.
So this concept is not there in system Verilog, right?
In system Verilog, we are using virtual. Okay, Bhagwan. See, in system Verilog, go to the driver. This is driver. What I have written here?
Yeah. Okay, maybe because we just saw one interface in the diagram, I got confused and I thought
No. They have given it like this. I don't know why, but yes, what if you see in the environment only we are passing. See, here whatever the interface I am passing to driver, same interface I am passing to the monitor. Am I passing different? No, same only.
So actually sorry, I understood that virtual interface has like the DUT or the interface is actually pins.
Yeah, exactly. Interface is actually static. All the pins are present in the interface. It is a static part. Okay. We
Okay.
can't delete it. When I'm saying virtual interface, now see, whenever I'm writing this test image, okay, I have written this virtual interface. That means whenever my environment is created, at that time only this virtual interface is created. Else there is no existence of this virtual interface. So this virtual interface, it is like the pointer to the interface.
Okay.
So why we are using virtual interface? Because our class is dynamic, interface is static. We cannot use static inside a dynamic. You just think interface must be present from the start of the simulation. But from the start of the simulation, my environment class is not present. So how it is possible? Okay, so that's why we are using this virtual interface concept.
So Priya, that means this concept, can you go back to the diagram? So this interface and virtual interface, this is also there in system Verilog, but we are not writing in the we are not drawing these two separately in the diagram, right?
No. That is not the thing. Maybe whatever the diagrams I have shown you there, it is not present. See, diagram point of view, some person they show this virtual interface, and some just omit. Just they do monitor to driver connects.
But yeah, this is good. Yeah. Because of this, I can clearly understand that, I can clearly remember that virtual interface.
Okay, now I got your point. In the system Verilog, it was just like interface to driver connection. So you thought, no. See, they have shown this one. You can see it is like in the dotted part. Okay, so why they started with this virtual interface? It is not always present. Okay, so you can see, you can explain like interface to driver also. It is not a issue. But virtual interface, so what I told you, however we are writing the codes in system Verilog, same will be in UVM. See, now what is the difference will be in UVM? In the system Verilog code, we are passing from this environment, right? But in UVM also that passing concept will be there. Okay, now here we are passing through this class argument, through this constructor, but in UVM we will be using config DB. But same virtual interface will be there. We will be storing it at some place, and driver and monitor will use them.
Okay.
Methods are different, but concept is same. Okay. We will see tomorrow. Okay. Now what is this sequence item? This sequence item, if you look into the sequence item, these things I'll be covering later. Okay, I'll one by one.
Sure.
This sequence item like this. See, if you remember, say these things are in the system Verilog. This part, it is in Verilog. So what are these parts? What will happen whenever I'm writing this part? If I'm not writing, then what will happen? We will see it in the next class.
Okay.